Ever feel like you're constantly running algorithms in your head, even if you don't realize it? Get ready to dive into the fascinating world of Algorithms to Live By, a book that explores how computer science principles can actually help us navigate those everyday dilemmas.
It takes those complex concepts from computer science, like sorting or caching, and shows how they're surprisingly relevant to decisions we make all the time.
So the book essentially argues that we can apply these algorithms to everything from finding an apartment to choosing a partner.
Yeah. It's all about finding those clever shortcuts, especially when we're faced with tons of options and limited time.
Okay, so how do we unpack this?
Well, one of the most intriguing concepts is this idea of optimal stopping,
Optimal stopping.
which is all about knowing when to stop searching and make a decision.
Okay.
So think about apartment hunting in a competitive market. You don't want to settle for the first place you see,
Right.
but you also don't want to keep looking forever and miss out on great opportunities.
How do you find that sweet spot? Is there some magical formula?
Well, the book introduces this idea called the 37% rule.
The 37% rule.
It sounds a bit counterintuitive, but the math suggests that if you want to maximize your chances of finding the best apartment,
Okay.
you should actually pass on the first 37% of the options you see.
Wait, so I should just ignore those first 37% of apartments no matter how good they seem. What if I miss out on a hidden gem?
The idea is that by observing that initial 37%, you're kind of setting a baseline.
Okay.
Then the very next apartment that surpasses that baseline is statistically the one you should go for.
Hmm.
It's all about maximizing your chances of finding the absolute best, even in a huge pool of options.
That's wild. So how does this 37% rule apply to other areas of life? Like, say, finding a job or even a partner. Should we be swiping left on the first 37% of potential matches on a dating app?
Well, it gets a bit trickier when we're dealing with complex human factors.
Right.
The book actually shares a funny anecdote about one of the authors who tried using this algorithm to find a wife.
Oh, no.
Let's just say it didn't quite work out as planned.
That makes me feel a bit better about my own dating misadventures. But seriously, it's a good reminder that algorithms can be helpful guides, but they shouldn't dictate our every move.
Yeah,
We have to factor in our own intuition and the messy realities of human relationships.
absolutely. And it also highlights that these algorithms often work best when there's a clear objective and a limited time frame.
Okay.
The book even applies optimal stopping to something as mundane as finding a parking spot.
Okay, now I'm really intrigued. Tell me
Ah.
more about this algorithm for perfect parking.
It's all about balancing the desire to park close to your destination with the risk of driving around forever and ending up even further away.
Okay.
The math suggests that there's an optimal point at which you should stop searching and grab the next available spot.
So maybe there's a mathematical solution to my parking woes after all.
But it also makes me wonder about those times when we might give up too easily. Maybe we're settling for good enough when we should be exploring more options. That's a great point. Research actually shows that people tend to stop searching too early, missing out on potentially better opportunities.
Oh.
Which brings us to another fascinating concept from the book, the explore-exploit dilemma.
Okay, let's dive into that. What is this explore-exploit dilemma all about?
Think about it like this. You're scrolling through your music streaming service.
Okay.
Do you stick with your tried and true playlist knowing you'll enjoy every song?
Yeah.
Or do you venture into uncharted territory exploring new artists and genres?
That's a dilemma I face every day. So is there an algorithm for finding that perfect balance between old favorites and new discoveries?
The book suggests that the optimal balance actually shifts throughout our lives.
Hmm.
When you're younger, you have more time to kind of play the game,
Yeah.
so it makes sense to explore more, try new things, see what sticks.
So my youthful tendency to jump from one hobby to the next was actually algorithmically sound. I feel so validated right now.
But as we get older and time becomes more precious, it makes sense to exploit more, savor those favorite restaurants, revisit beloved books, spend time with cherished friends.
Okay.
It's not about closing ourselves off to new experiences, but about recognizing that the value of exploration changes over time.
There's an algorithm for aging gracefully. Now I'm curious about how this explore-exploit concept plays out in other areas of life.
It has fascinating implications for fields like web design.
Okay.
Think about A/B testing on websites. Designers are constantly experimenting with different layouts and features to see what leads to more engagement or sales.
Right.
That's essentially an explore-exploit process in action.
So those annoying pop-up ads are just a grand algorithmic experiment. Fascinating. But how does this apply to something as complex as medicine?
Imagine a clinical trial for a new drug.
Okay.
Traditionally, patients are randomly assigned to different treatment groups.
Right.
But what if you could use an explore-exploit approach to potentially improve outcomes for patients during the trial itself?
So instead of waiting until the trial ends, you'd adjust treatments based on early results.
Yeah.
That sounds ethically tricky, but potentially groundbreaking.
It's a complex issue, but adaptive clinical trials, as they're called, are gaining traction as a way to potentially make medical research more efficient and effective.
It's amazing how these seemingly abstract ideas from computer science can have such a profound impact on our lives.
Yeah.
Okay, I'm ready for the next algorithmic adventure. What's next on our list?
Let's talk about sorting.
Sorting, like organizing my sock drawer. How can that be an algorithm?
Think about it from arranging books on a shelf to understanding social hierarchies. Sorting is about bringing order to chaos.
Okay.
And as the book points out, the more items you have, the harder it becomes to sort efficiently.
Which explains why my closet always ends up looking like a tornado hit it.
Well, the book talks about how different sorting algorithms have different levels of efficiency.
Okay.
There's this simple but slow bubble sort where you compare adjacent items and swap them until everything's in order.
That sounds like how I sort laundry. Incredibly inefficient.
Right. And then there's the more sophisticated merge sort, which uses a divide and conquer approach to achieve much faster results.
Okay.
It's like breaking down a big problem into smaller, more manageable chunks.
So what you're saying is that if I want to finally conquer my closet chaos, I need to ditch my random approach and embrace the power of merge sort.
It might just change your life. But what's really intriguing is that the book also applies these sorting principles to things like sports tournaments.
Oh, really?
Single elimination tournaments are like bubble sort fast, but prone to upsets.
Okay.
Ladder tournaments are like the slow and steady bubble sort.
Got it.
And bracket tournaments like March Madness are the merge sort of the athletic world.
It's fascinating how these sorting algorithms are reflected in the very structure of competition. My brain is officially in algorithm overdrive.
We're just getting started. Now let's delve into a concept that's essential to how computers work, but also has surprising relevance to our everyday lives: caching.
Okay, my brain is officially in algorithm overdrive, but I'm ready for more. You mentioned caching.
Yeah.
Now, I know computers use caching, but how does that apply to real life?
Well, think of it like this. You're working on a project and you keep reaching for the same few books and documents.
Yeah.
Instead of going back to the bookshelf every time you keep those key resources on your desk for easy access,
Right.
that's essentially what caching is: storing frequently accessed information in a readily available location.
So my messy desk piled with books and papers is actually a sophisticated caching system. I knew there was a method to my madness.
Well, maybe not that sophisticated.
Okay.
But the book talks about how computers use caching to speed up processing.
Right.
And our brains do something similar with memories.
Right.
We prioritize information based on how recently and how often we use it.
Which explains why I can remember what I had for breakfast this morning, but can't find my keys to save my life. But how does a computer decide what to keep in its cache and what to evict? It can't hoard everything forever.
Right. One of the most common caching algorithms is called least recently used, or LRU.
LRU.
It's based on the idea that the things you've used most recently are likely the ones you'll need again soon.
Okay.
And the things you haven't used in a while can be safely pushed further down the memory hierarchy.
That makes sense. It's like that stack of papers on my desk. The stuff I need most often naturally ends up on top. But the book mentions a really cool twist on this library analogy, right?
Yes, it proposes turning the library inside out, in a sense.
Okay.
What if, instead of hiding recently returned books away in the stacks, libraries displayed them prominently, creating a sort of human cache of the most in-demand items?
That's brilliant. We would definitely make finding popular books easier. And it taps into this whole LRU principle. It's like a real-life recommendation algorithm. The book also talks about how caching applies to physical spaces, like Amazon warehouses, right?
Absolutely. Amazon prioritizes frequently purchased items by placing them in more accessible locations within their massive warehouses, making retrieval and shipping faster. It's a real-world example of how caching principles can optimize efficiency on a massive scale.
So even in the age of algorithms, physical location still matters. I never thought about it that way. But it makes sense, and if we connect this back to our own brains, it's a reminder that we're constantly caching information, prioritizing what's relevant, and forgetting things we haven't accessed in a while.
Okay, I'm ready to tackle the next big idea: what's on our algorithmic agenda.
Let's talk about overfitting.
Overfitting.
It's a concept that's especially relevant in our data-driven world where we're bombarded with information and trying to make sense of it all.
I definitely feel like I could use some help with that. Tell me more.
Imagine you're trying to figure out what makes a marriage successful.
Okay.
You could create a simple model based on a few key factors like communication and shared values.
Right.
Or you could build an incredibly complex model that takes into account dozens of variables, everything from income levels to astrological signs.
Okay, I'm guessing the more complex model is better, right? More data, more insights. Not necessarily a simpler model, might be more accurate in predicting future marital happiness
Oh,
because it captures the underlying trends without getting bogged down in all the noise.
okay.
The complex model might fit the existing data perfectly,
Right.
but could be overfitting, mistaking random fluctuations for meaningful patterns.
So sometimes a simpler explanation is actually more powerful. That's counterintuitive, but it makes sense. Where else does this overfitting problem pop up?
It can happen in all sorts of domains, from finance to fitness.
Okay.
Think about someone who obsessively tracks every tiny fluctuation in their weight or body fat percentage.
True.
They might be overfitting the data, missing the bigger picture of their overall health and well-being.
That's such a good point. Like getting lost in the weeds and missing the forest for the trees. It makes me think about how sometimes less is more when it comes to information.
The book talks about a technique called cross-validation,
Cross-validation.
where you test a model on unseen data to see how well it generalizes. If a complex model performs perfectly on the training data but bombs on the new data, that's a big red flag for overfitting.
It's like studying for a test by memorizing the answer key instead of actually understanding the material. You might ace that specific test, but won't be able to apply the knowledge to new situations. So how do we avoid this overfitting trap in our own lives?
One key is to recognize our limitations.
Okay.
We can't possibly consider every factor in every decision, and that's actually a good thing.
Okay.
Our natural constraints, time, energy, memory, often push us towards simpler solutions, even if we don't realize it.
So our limitations are actually a form of built-in overfitting prevention. That's an interesting way to look at it. I'm starting to see how these algorithmic concepts can really shift our perspective. Now let's dive into a world that's always fascinated me, the world of game theory.
Game theory is all about understanding how people make decisions when the outcome depends not only on their own choices, but also on the choices of others.
Okay.
It's like a giant game of strategy where everyone is trying to anticipate the moves of their opponents.
So it's like chess, but with real-life consequences.
In a way, yes, one of the classic examples is the prisoner's dilemma,
The prisoner's dilemma.
where two suspects are interrogated separately.
Okay.
Each prisoner has to decide whether to stay silent or betray the other.
Right.
If they both stay silent, they get a lighter sentence.
Okay.
If one betrays the other, the betrayer goes free and the other gets a harsher sentence.
Got it.
And if they both betray each other, they both get a moderate sentence.
Okay, I'm seeing the dilemma. What's the best strategy?
The tricky part is that from each prisoner's individual perspective, betraying the other always seems like the best option, regardless of what the other prisoner does. Even though both prisoners would be better off if they cooperated and stayed silent, the rational choice for each individual is to betray.
So even though cooperation would lead to the best overall outcome, self-interest leads to a worse result for everyone. That's a bit depressing. How does this play out in real life?
The prisoner's dilemma is a powerful framework for understanding all sorts of situations where individual incentives clash with collective well-being.
Okay.
Think about environmental issues like climate change.
Okay.
Everyone benefits from a healthy planet, but individuals might be tempted to overuse resources or pollute if it benefits them in the short term.
It's like everyone grabbing as much as they can from a shrinking pie, even though it means there's less pie for everyone in the end.
Exactly. Or think about those Black Friday sales where people trample each other to get the best deals.
Right.
Everyone would be better off if they just shopped calmly. But the fear of missing out drives people to act in ways that are ultimately harmful to everyone.
It's a good reminder that sometimes we need to think beyond our immediate self-interest and consider the long-term consequences of our actions. So is there a way to escape this prisoner's dilemma trap? Can we design systems that encourage cooperation instead of competition?
That's where the concept of mechanism design comes in.
Mechanism design.
It's about changing the rules of the game to incentivize better behavior. For example, imposing taxes on pollution or creating rewards for sustainable practices can help align individual incentives with the collective good.
So it's not just about accepting the prisoner's dilemma as inevitable,
Yeah.
but about finding creative ways to change the game altogether.
Exactly. And the book delves into how this idea of mechanism design can be applied to everything from auctions to voting systems, even to designing better online dating platforms.
Okay, I'm starting to see the world through a whole new lens, a game theory lens where everything is a strategic interaction.
And don't forget the role of emotions.
Right.
We're not always rational actors, and sometimes our emotions can lead us to make decisions that seem illogical from a purely strategic perspective.
So how do emotions fit into this game theory framework? Are they just noise in the system or can they be strategic?
Sometimes acting irrationally can be a strategic advantage.
Okay.
Think about the value of a reputation for being vengeful.
Oh,
If people know you'll retaliate if they wrong you, they might be less likely to take advantage of you in the first place.
so sometimes a little bit of unpredictability can actually be a good thing. It's like that saying, keep your friends close and your enemies guessing.
There's some wisdom in that, and speaking of unpredictability, the book also explores the power of randomness in strategic situations.
Okay, now I'm really curious. How can randomness be a good strategy? It seems like the opposite of what an algorithm would recommend.
In some situations, being unpredictable is the best way to avoid being exploited.
Hmm.
Think about playing rock, paper, scissors.
Oh,
If
yeah.
you always play the same hand, your opponent will quickly figure out your pattern and beat you every time.
Right. The best strategy is to be completely random, making it impossible for your opponent to predict your next move.
Exactly. This principle of unpredictability applies to other areas of life as well.
Okay.
Sometimes being a bit of a wild card can be a powerful way to keep your opponents off balance and gain an advantage.
It makes me think about those times when I'm trying to negotiate a better deal or navigate a tricky social situation.
Yeah.
Maybe a little bit of calculated randomness wouldn't hurt, but how do you actually introduce randomness into a situation? Is there an algorithm for that?
Computers use sophisticated methods for generating random numbers, and there's some interesting parallels in human behavior.
Okay.
Think about John Rawls's Veil of Ignorance,
Veil of
a
ignorance.
thought experiment about designing a just society.
I vaguely remember that from a philosophy class.
Yeah.
It's about imagining yourself behind a veil where you don't know your own social status, talents, or fortune.
Exactly. Rawls argued that from this perspective of not knowing who you'll be in society, you'd be more likely to choose principles that benefit everyone, not just yourself.
So it's like a way of removing our own biases and self-interest from the equation.
The book points out that this veil of ignorance is essentially a form of randomness.
Okay.
It forces us to consider all possible perspectives, not just our own limited viewpoint.
That's such a powerful concept. It makes me think about the importance of empathy and trying to see the world through the eyes of others.
It's also a reminder that randomness can be a catalyst for creativity.
Okay.
Sometimes our best ideas come when we break out of our usual patterns and routines and allow for a bit of chance to guide us.
So instead of always trying to control every detail, maybe we should embrace a little bit of chaos.
There's a technique called simulated annealing
Simulated any.
that's inspired by the way metals are heated and cooled to achieve specific properties.
Okay.
In the context of problem solving, it involves introducing random variations into a solution and then gradually reducing the randomness as the solution improves.
Okay.
It's a way of exploring a wider range of possibilities and avoiding getting stuck in local optima.
So it's like shaking up a snow globe and seeing where the flakes settle.
Exactly. And the book gives an example of how this is used in communication systems.
Okay.
When a device encounters congestion on a network, it backs off for a random amount of time before trying to resend the data. It's called exponential backoff.
Exponential backoff.
So instead of everyone trying to resend their data at the same time and causing even more congestion, they introduce a bit of randomness to smooth out the flow.
So instead of everyone trying to merge at the same time, they chill out for a random amount of time, and maybe things wouldn't be such a chaotic mess.
That's a perfect analogy. Okay, your mind is officially blown wide open. This whole idea of strategic randomness is a game changer. But now I'm curious about another concept you mentioned earlier, recursion. It sounds a bit intimidating.
Recursion. Yeah, it does sound kind of intimidating.
Recursion is a bit like looking into a mirror and seeing an infinite reflection of yourself.
Okay.
It's about solving problems by breaking them down into smaller, self-similar subproblems.
Okay. I'm going to need a real-world example to grasp this one.
Think about planning a trip.
Okay.
You might start by deciding on your destination, then break that down into choosing flights, accommodations, and activities. Each of those subtasks can then be further broken down into even smaller steps, like researching hotels or booking tickets.
So it's like a nested set of to-do lists where
Right.
each item can be expanded into its own sublist.
Exactly. And the beauty of recursion is that it allows us to tackle complex problems by applying the same logic repeatedly at different levels of detail.
It reminds me of those Russian nesting dolls.
Hmm.
You open one and there's another one inside and another and another. It's like an endless puzzle.
That's a great analogy. And the book explores how this concept of recursion applies to human thinking and social interactions.
Mm.
It can get a bit mind-bending, but it offers some fascinating insights into how we make decisions and understand the world around us.
Okay, I'm ready for a mind-bending challenge.
Yeah.
How does recursion work when it comes to human behavior?
Let's take investing as an example.
Okay.
Remember that famous quote by John Maynard Keynes?
Oh, boy.
Successful investing is anticipating the anticipations of others.
Okay.
It's not just about what you think a stock is worth, but what other people think it's worth and what they think other people think it's worth, and so on.
It's like a recursive loop of speculation.
Exactly. And this type of recursive thinking plays out in other areas of life, from poker to politics.
Okay, I need a poker analogy. I love poker.
Think about bluffing.
Okay.
A successful bluff depends not only on your opponent's hand,
Right.
but also on their perception of your hand and their perception of your perception of their perception, and so on.
Wow, that's deep. No wonder poker is such a challenging game. So this recursive thinking, is it a good thing or a bad thing?
It can be both. It's important to be aware of these layers of recursion, but also to recognize that going too deep down the rabbit hole can lead to overthinking and paralysis.
So it's about finding a balance between considering the perspectives of others and not getting lost in an endless loop of what ifs.
Exactly. And the book also explores how recursion relates to game theory.
Okay.
Remember our discussion of the prisoner's dilemma and the search for equilibrium?
Yes. It's all starting to come together now.
Well, finding a stable equilibrium in a game often involves a recursive process of reasoning about the best response to the anticipated actions of others. It can get pretty complex.
So even with algorithms and computers predicting human behavior is a tricky business?
It's a good reminder that human behavior is complex and often unpredictable. But even if we can't always find the perfect solution, game theory and the concept of recursion can provide valuable insights into how people make decisions in strategic situations.
This is all so fascinating. It's like I'm seeing the world with new eyes, recognizing all these recursive patterns playing out around me.
And the book encourages us to be more mindful of these recursive processes, recognizing that our actions and perceptions are often intertwined with the actions and perceptions of others. We're all part of a complex system where our choices can have ripple effects we might not even anticipate.
Okay, I'm definitely going to be paying more attention to those recursive dynamics from now on. Now let's talk about something that feels incredibly relevant to my life right now. How to make better decisions when I have limited information and the future feels uncertain.
That's where the book gets really practical, offering strategies for dealing with real-world dilemmas that don't always have clear-cut solutions.
Okay, I'm all ears. What are some of those strategies? So how can we apply this algorithmic thinking to those like real world messy situations where the answers aren't always clear?
The book emphasizes that sometimes the best approach is to embrace simplicity and avoid overcomplicating things.
So when in doubt, go with my gut.
Not exactly. It's not about ignoring information or logic, but about recognizing that sometimes simple heuristics can be more effective than trying to calculate the absolute best solution.
Okay, I'm intrigued. What are some examples of these simpler heuristics?
One classic example is the 1N rule.
1N rule.
It suggests dividing your resources equally among all available options when you have no information about which option is best.
So if I'm trying to decide how to invest my money and I have no idea which stocks are going to perform the best, I should just split my investment equally across all of them.
It might sound overly simplistic, but in the absence of any other information, it can be a surprisingly effective strategy. It prevents you from putting all your eggs in one basket and missing out on potential winners.
It's like that old saying, don't put all your eggs in one basket. Maybe there's some hidden algorithmic wisdom in those old sayings.
There just might be. The book explores other simple heuristics that can be surprisingly effective, like using a timer to manage your time or prioritizing tasks based on their estimated completion time.
So it's not about ditching logic or planning altogether,
Right.
but about recognizing that simpler approaches can often be more effective and less stressful than trying to optimize every single decision.
Exactly. The book reminds us that in the real world, we're often dealing with incomplete information and limited time.
Right.
In those situations, simple heuristics can be incredibly valuable.
It's a good reminder to sometimes just get started and adjust as you go, rather than getting stuck in analysis paralysis. It's like that Nike slogan, just do it,
There you go. The book also talks about the importance of satisficing.
which is finding a solution that's good enough rather than striving for the absolute best.
So it's about letting go of perfectionism and recognizing that good enough is sometimes good enough.
Exactly. The book argues that in many situations, spending excessive time and effort trying to find the optimal solution just isn't worth the extra benefit.
It's about finding that sweet spot between maximizing your outcome and minimizing your effort. Work smarter, not harder, right?
Right. The book offers specific strategies for applying this satisficing principle, like setting time limits for decision making and focusing on a few key factors rather than getting bogged down in every little detail.
So it's about figuring out what really matters and letting go of the need to control every little thing. It makes a lot of sense, but sometimes it's hard to know what really matters, especially when you're thinking about the long-term consequences of your decisions.
That's where the concept of discounting comes in.
Discounting.
It's about weighing future rewards and costs against present ones. Oh, I can definitely relate to that. I'm often guilty of prioritizing immediate gratification over long-term benefits, like choosing that extra slice of pizza even though I know I'll regret it later.
We all do it. It's human nature to value things more highly when they're closer in time.
Right.
But the book emphasizes the importance of taking a long-term perspective. The decisions we make today can have ripple effects far into the future.
It's a good reminder to think about the bigger picture and consider the potential consequences of our choices, both good and bad. So how do we get better at making those long-term decisions?
The book suggests strategies like setting clear goals, planning for the future, and considering the potential impact of our choices on others. It also highlights the importance of learning from our experiences.
Right, experience is the best teacher, but how can algorithms help us learn more effectively?
One key concept is reinforcement learning.
Reinforcement learning.
It's about learning through trial and error, adjusting our behavior based on feedback from our environment.
So it's like a system of rewards and punishments that shapes our behavior over time.
Exactly, and the book explains how this type of learning is used in all sorts of applications, from developing artificial intelligence to understanding human psychology.
So even when we're not consciously aware of it, we're constantly learning and adapting based on feedback from our environment. Fascinating. But the real world often throws us curveballs. Things don't always go according to plan. How do algorithms handle those unexpected twists and turns?
That's where the idea of robustness comes in.
Robustness.
It's about designing systems that can handle uncertainty and adapt to changing conditions.
So it's about building in some flexibility and resilience,
hmm
recognizing that we can't predict everything.
Exactly. The book uses the example of fault-tolerant systems. Think about the internet.
Okay.
It's a vast network of interconnected devices, and yet it's incredibly resilient if one server goes down. Data packets can be rerouted through other paths, keeping the information flowing.
It's like a highway system with multiple routes and detours. If there's an accident or construction, you can still get to your destination, even if it takes a little longer.
That's a great analogy, and this principle applies to other areas of life as well. It's about having backup plans, being adaptable, and not being afraid to course correct when things don't go as expected.
So roll with the punches.
Exactly. The book offers strategies for building more robustness into our lives, like diversifying our investments and developing multiple skills and sources of income.
It's a good reminder that change is inevitable, and the best way to navigate those changes is to be prepared and adaptable. But with all this talk of algorithms and optimization, I'm wondering, is there a risk of becoming too focused on efficiency and logic and losing sight of the human element?
That's a really important point. The book strikes a balance between embracing algorithmic thinking and recognizing the limits of logic. It emphasizes that algorithms are tools, not masters,
Right.
and we should use them thoughtfully, always keeping in mind our values and goals.
So it's about using algorithms to enhance our decision-making, not to dictate our lives.
Precisely. And the book reminds us that even with the best algorithms, there's always an element of chance and uncertainty.
Embrace the unknown, stay curious, and keep exploring.
That's the spirit.
This deep dive has been incredible. I'm walking away with a whole new perspective on myself, my choices, and the world around me. It's like I've been given a new set of mental tools to navigate the complexities of life.
And remember, even with the best algorithms, there's always an element of chance and uncertainty. Embrace that mystery, stay curious, and never stop exploring.
That's the perfect note to end on. I'm feeling inspired and ready to apply these algorithmic insights to create a more fulfilling and meaningful life. Thanks for joining me on this amazing journey.